this video is going to continue with completing the square. So in our notes we have our steps for completing the square. Just to remind you again, the only reason we would use these steps is if the problem can't be factored or you just like doing it this way. Every problem can, in this form, can be done using completing the square, but most people only use this method when the original problem cannot be factored. Okay, so if we take a look at example 9, there's two good ways to start this problem. One way is just like before we started this section. If there's something that divides all the terms, we can start with that. Or you can just use step 1, which pretty much says divide each term of the equation by a. So remember, a is the number in front of the x squared. We want this to be 1. So we want this to be a positive 1. So step 1 is we want to divide everything by a negative 2. So then we would have x squared minus x equals 12. So that was step 1. Step 2, we want the constant by itself. So it already is, so we can skip step 2. Step 3, so I would do this on the side. Step 3 is you take the number that is in front of the x. So take the number that is in front of the x and divide it by 2. I'm going to take this number here, which is negative 1, and I'm going to divide it by 2. And since 2 doesn't go evenly into negative 1, I'm just going to leave it as negative 1/2. So that was step 3. Step 4, it says to take this number and square it. So negative 1/2 squared. So negative 1/2 times negative 1/2, so negative 1/2 times negative 1/2. And again, you have a calculator that can do that as well if you're having trouble. And you would get positive 1/4. So that was step 4. Then step 5, it says that we're going to add this number that we just found, the 1/4, to both sides. So we're going to add 1/4 to both sides. So we have to do 12 plus 1/4. If we were doing that without a calculator, we'd have to find a common denominator. So I'm going to use the calculator to go faster. 12 plus 1/4. Okay, it's 12 and 1/4. I prefer improper. I'm going to change it to improper. So 49/4. Okay, so this was step 5. And then the whole purpose for doing this is to be able to do step 6. So step 6 says the trinomial that we have here should be factorable such that it's the same number times the same number. So we have to think of what number multiplies to 1/4 and adds to negative 1. So we're factoring this. But this should not be difficult because the answer is always going to be step 3's value. So negative 1/2 times negative 1/2 should multiply to 1/4, and it should add negative 1/2 plus another negative 1/2 should add to this value here. So it's always this number here that you're going to use right now. So it's going to be x minus 1/2 times x minus 1/2. So again, the whole point in doing all this work that we just did is so that you can write it as a square. And why is that so valuable? Well, now you can write it as x minus 1/2 to the second power. And that is powerful because now we can use the video notes that we took for examples numbers 1 through 7, and now we can solve it the same way. So to get rid of an exponent, we would need to place a square root into the problem because 2 goes into 2 once. So this will go away and just leave us 1. So I don't need to put those parentheses there. And whatever we do to one side, we do to the other. So since we're square rooting both sides, or on the left side, we need to square root the right side. That is exactly why I always want to leave this as an improper fraction. So I did not want to leave it as an mixed number, because now I can split this up as the square root of 49, which is 7, and the square root of 4, which is 2. Now remember, whenever we put one of these symbols into a problem, we need plus or minus. So we need plus or minus. We talked about why that was in the previous video. So now to get x by itself, we're going to add 1/2 to both sides. Whatever we do to one side, we have to do the other. Alright, so now, x is now by itself, so we get positive 7/2 plus 1/2 as one of our answers. And then we get negative 7/2 plus 1/2 as an answer. So you can do this in your calculator, or I'm going to do it without, because 7 plus 1, since they have a common denominator, 7 plus 1 is 8. And then 8 divided by 2 is 4, so that's one answer. And then negative 7 plus 1 is negative 6. And negative 6 divided by 2 is negative 3. Now, when you get an answer that does not have a radical in the final answer, it means we could have factored this problem instead. So again, the whole point in completing the square is to do a problem that can't be factored. Alrighty. And then again, we can always go back to our original problem, which was negative 2 times x squared. So I'm going to go ahead and plug in 4. So 4 squared plus 2 times 4. And then I click equal, and it should be negative 24, which it is. So then I would know that this solution is correct. And then I would check this one. Due to time, I'm going to go ahead and just show you again one, because the other one is done the same way. Just make sure to use parentheses when you plug this one in. Alright, let's go ahead and try another example. Now, number 10, let's see if this is factorable. So if I want to solve this using factoring, can I think of anything that multiplies to 2 and adds to negative 6? No, you can't. So this is exactly a problem why you want to know how to complete the square, because we can't factor it. That's the only way we know how to solve this as of right now. So we're going to go ahead and use our steps here. The first step, step number 1, is we want the number in front of the a term to be 1. So since it already is, step 1 we can skip, because it's already 1. Step 2, we want the constant by itself. So we're going to subtract 2 to both sides, so the x's are together and the constants on the other side. So this was step 2. Then step 3, I'm going to do that in the corner of my paper on the side here. Step number 3, I want to divide the number in front of the x, so this number right here, the negative 6, I'm going to divide it by 2. And then, step 4, we're going to go ahead and square that number there. So we're going to, step 4, take the negative 3 and square it. And that would be 9. And then step 5, we're going to add that 9 to both sides. Now we have x squared minus 6x plus 9 equals 7. Now the whole point of doing this, so if you're worried, what if I accidentally square and then divide? If you're worried you're going to flip-flop these two here, you're okay. You will catch your mistake if you accidentally switch these steps, because when you put that number here, this won't be able to be factored as a square. So step number 6 won't work if you flip these two steps by accident. So you'll catch your mistake, in other words. So it does matter. Dividing by 2 has to happen first and then square after, or else this won't happen. What multiplies to 9 and adds to negative 6? It's always going to be this number right here. Negative 3 times negative 3 multiplies to 9 and adds to this. So that's why I like to be organized in my work and write it out. So that way when I factor, it makes it so much easier. And remember, you can write that down as x minus 3 to the second power. And now we have completed the square, and we can now solve by using the square root property. So we can square root both sides, and remember when we square root both sides we need a plus or minus symbol. This will make the radical go away, those will undo each other. And then to get the x by itself, we're going to add 3 to both sides. Well, we can't add 3 to a, this is not 7. You can't do 7 plus 3. This is a decimal number. So it doesn't matter if the 3 goes first or it goes after. I like to put the 3 in the front, so that way it doesn't look like it's inside the radical. But again, you could also write plus or minus 7, and then the 3 after if you want. I just prefer it this way. So that would be the exact answer as long as this is simplified, which there is no number in our perfect square list that goes into 7, so that's how I know that that's completely simplified. So this is called our exact answer, 3 plus or minus square root of 7. And then our approximate answer is what we get when we put this in our calculator. So 3 plus square root of 7. That's going to be one answer. And our directions at the beginning say round to the 100th place. So 100th place means only 2 decimals. So we have to go to the third number. Since it's 5 or higher, it's going to be 5.65. So that's going to be one answer. And then we're going to do it again. And if you have one of these calculators, you can just click up and change the plus now to the minus sign right here. 0.35. So those are 2 answers as an approximate, what this is about. So now if I want to check this, if I use the decimal, it won't be exactly 0. It just will be about. So let me demonstrate that. So I'm going to go ahead and use 5.65. So I'm going to go ahead and plug in 5.65. Whoops. 5.65, and then square. Minus 6 times 5.65, and then plus 2. And I want to make sure if my answer is right that it equals 0. But it doesn't equal 0 because I used an approximate. So I want to make sure that it's about 0, which it is. If I want to make sure I'm 100% correct, I would need to type this in. So now instead, I'm going to do the same thing, but instead of typing in the decimal, which is easier to type in, I'm going to type in 3 plus the square root of 7. So I have to make sure to put the double parentheses there, and then square it, minus 6 times, and I need to put this in parentheses because it's all what x is, 3 plus square root of 7. See, this just takes a little bit longer to type in. And then plus 2, and this time when I click equals, it will say 0. Whoops, I must have done something wrong. Oh, I see what I did wrong. I put too many parentheses here. Okay, now, it will say 0. So again, you can use these to check if your answer is right, but it won't give you that exact number. It should be pretty dang close though. If you plug in the exact, that's the difference between exact and approximate. If you plug this in, you'll get exactly the right answer. Now, I wrote this as 3 plus or minus radical 7. On Alex or on whatever homework system you're using, it might want you to type it in twice because they are making sure you understand that these are 2 different answers. So they might have you type in 3 plus radical 7, comma, and then 3 minus radical